Let's complete this topic by learning inference rules of first order logic. Okay, in first order logic we have four inference rules. One by one we'll see. First one, universal generalization. Okay, so p of x, then for all x p of x. We know inference rules, isn't it? This is premise, this is conclusion. Whenever premise is true, then we can conclude this one. Okay, example, why this is a valid rule I will tell you. Example, p of x is nothing but a statement called a byte has, okay, a byte has 8 bits. Okay, this is the information. Just interpret it like p of x means a byte x, the name of the byte is x. A byte x has 8 bits. Okay, now for all x, p of x means every x, the x means any byte. Now every byte has 8 bits. Correct or not? If one particular byte has 8 bits, p means 8 bits, then for all x p of x is obviously true. Every byte has 8 bits. For all x means every x. X means a byte name. Then every byte. Correct? So if one particular byte has 8 bits, then every byte has automatically 8 bits, isn't it? If that is true, then this rule also should be true. Correct? So this rule is called universal generalization. From now onwards, we can generalize like this. Let's take second valid rule, that is universal instantiation. If something is true for everyone, then for a particular one also it is true. Example, same thing. If every byte has 8 bits, then a particular byte has 8 bits, isn't it? So this is obvious to see, right? Now we'll see third one, existential generalization. P of C, then there exists x p of x. That means for some C, if some formula P is true, let's say C is Raju, okay, a constant. Raju has passed physics exam, let's say. Raju has passed physics exam. Then can I say that some student passed physics exam? Obviously, right? That's why if Raju is C here, C has passed physics exam, then there is someone who has passed physics exam. That's why this is a valid rule. This is called existential generalization. So whenever you have P of C, we can replace it with there exists x P of x. Now fourth one, existential instantiation. Okay, we can instantiate from this there exists x. That means if there exists someone who passed physics exam, okay, if you know that, that means someone passed physics exam, let's say someone passed physics, then we can do this one. We can say that P of C, then C passed physics exam, okay, C passed physics exam. But be careful that C should be always new C. When you introduce C, then that C should be new C. So that means I will tell you what does it mean. So whenever you want to use this rule, from there exists x p of x, if you want to conclude P of C, that C should be new constant. Only every time when you use this, we have to introduce new constant. Don't take the existing constants in the proof. These are all things we use in proof theorem, I mean proving something. Then in that proofs, when you use this rule, this C should be a new variable or constant. Example I will tell you. What is the mistake commonly people do? P of x. There exists x P of x, let's say. Whenever there exists x P of x is true, let's say if you conclude that Raju passed physics exam, P of Raju, yes, you can conclude, okay. Then Raju is a new person, like new person, okay. Now in theorems, again, if there exists x q of x is given, then you can say q of Rani rather than Raju. Why? Because we should take a new constant. If you take old constant Raju, then already Raju is having this property. Then what happens, you see? There exists someone who passed physics exam, then you took him as Raju. Okay. Now second time there exists x q of x. If you don't take a new variable or a constant like Rani, then it becomes, you see, Raju passed chemistry exam, Raju passed physics exam, then Raju passed both exams. That is wrong concept, isn't it? If someone passed physics exam, someone passed chemistry exam, then that may not be same, right? That's why We have to introduce a new constant. Then only we can use this rule. So example, let me use that. There exists x p of x. Whenever you have, you can take p of Raju or anything. This is possible. Okay. Now one more time, if in the proof, if you have there exists x q of x like this, then take a new constant rather than old constant. Then only this formula can be useful. You can use it. Then p of Rani. Now you see, someone passed physics, let you assume Raju. Second time someone passed chemistry, you should assume different person, Rani. Then we are properly concluding the things. Understand? So these are the four rules. Generally in GATE exam we don't use them. So there is no question related to this. But if you understand them, that would be well and good. Let's solve some GATE questions related to this first order logic concept. The first one is, which of the following first order formula is valid? A formula is valid if it is true in all the cases. Okay. If you want to prove that something is not valid, that's easy. Prove that that formula is false. So always, my goal is to prove that some statement is false, because out of four options, one is valid, others are invalid, right? It is easy to recognize whether something is invalid or not. Okay. Simply prove that the formula is false. That's it. So automatically it will become invalid. That is what I am going to do now. Since it's a very big first order logic formula, how to simplify it? We use that technique. What is that? In the place of first order logic formula, we write a digital formula, right? So let me do that. What is beta here? Beta is some formula which is not related to this alpha of x. Beta is some unit of formula. Okay. So there is no free variable in it that is given. That means this entire thing is one formula. So we don't require to, we don't need to worry about that formula. Treat it as a unit. It's a bag. That bag contains a formula. Don't disturb it. Take it as a unit. Now beta implies there exists x alpha of x can be written as, I'm converting this to digital formula. Beta implies, let me convert this part. There exists x alpha of x is nothing but alpha 1 plus alpha 2. I am assuming two elements in the world. Then it will become alpha 1 plus alpha 2. Now let's simplify this part. So A implies B is nothing but A bar. That means beta bar plus alpha 1 plus alpha 2. Right? So this is the simplification of this one. Now implies, go to right side. This is for all x comma formula. Whenever you have formula for all x quantifier followed by comma, then that for all x is applicable for entire thing, like for beta and alpha of x. Okay, you remember it. It's like for all x formula. Then formula number 1, formula for first element, it will be beta implies, since beta does not contain any variable x, you write beta implies alpha of x will become alpha 1 first time, and second time we have to write it with element 2, isn't it? Beta implies alpha 2. So this is a simplification. So beta implies alpha 1 and beta implies alpha 2. We have to write this formula for 2 times. Now this will become beta bar, I am converting this, beta bar plus alpha 1 into beta bar plus alpha 2, isn't it? Now it will become beta bar plus alpha 1 into beta bar plus alpha 2 in digital will become beta bar plus alpha 1 alpha 2. Implication as it is, let me keep this implication. This will become beta bar plus alpha 1 plus alpha 2. Now the question is this kind of formula always true? Can we make it false? We'll try. To make this kind of formula false, so we can do it by making this one false, this one true. Let me try that. It's just attempt. Okay. Now beta bar plus alpha 1 alpha 2 false means beta bar should be false. Remember it. Alpha 1 alpha 2 should be false. Okay. So beta bar is false. But you remember our goal. Left side to right side false. For that beta bar should be false. You have option for alpha 1 plus alpha 2. Alpha 1 plus alpha 2 should be true, but alpha 1 into alpha 2 false. Yes, I got idea. Let's make alpha 1 true, alpha 2 false. True and false, false. This Same thing if I substitute here, alpha 1 is true, alpha 2 false. True or false, or true plus false? True, isn't it? So true plus false. True means 1, false means 0. 1 plus 0, 1, which is true. So finally, true plus false, true. Here true into false, false. False plus false, false. I got true false combination. So true implies false, false. You understand my goal? My target is making this formula false. Yes, I am succeeded in that. That means this formula is not valid. Understand? Let's take the second formula and we do the same. This time little bit faster. Now see, there exists X formula is nothing but formula 1 plus formula 2. Formula 1, beta implies alpha 1, first time with alpha 1, second time with alpha 2. So beta implies alpha 1 or beta implies alpha 2. This is the expansion of there exists X, isn't it? I am targeting this one. There exists X formula is nothing but formula 1 or formula 2, isn't it? Now if you simplify it, it will become beta bar plus alpha 1 plus this one beta bar plus alpha 2. I am converting into Boolean expression or digital expression. Beta bar plus alpha 1 plus beta bar plus alpha 2 will be beta bar plus alpha 1 plus alpha 1 plus alpha 2. So I don't want to disturb this implication. Let me keep this implication as it is. Otherwise formula will become very long. That's why. So let's keep this implication as it is. Let's convert this to again digital expression. Beta implies for all x alpha of x. For all of x alpha of x is nothing but alpha 1 into alpha 2, isn't it? So alpha 1 and alpha 2 or alpha 1 into alpha 2. Now you see again our target, otherwise you can simplify it. It will be beta bar plus alpha 1 into alpha 2, isn't it? A implies B is nothing but A bar plus B, A bar plus B. Now you see beta bar plus alpha 1 plus alpha 2 implies beta bar plus alpha 1 alpha 2. Our target is again same. Left is true, right is false. So to do that, to make right side false, beta bar should be false. This entire thing. Alpha 1 alpha 2 should be false. Remember it. So if beta bar is false, then false plus dash is our target, left side true, right? Remember it. So many times we did it. So right side false. For that, beta bar should be false, alpha 1 alpha 2 should be false. You just remember them. If beta bar is false but alpha 1 plus alpha 2 should be true, then only left side will become true. But alpha 1 alpha 2 should be false. Let's take alpha 1 true, alpha 2 false. True and false, false. True plus false, true. Got it? My idea? So my idea is making left side true, right side false, so that I get true false combination, or true implies false, true implies false is false. Really it's a valid formula. It cannot be false at any time, isn't it? That's why this is also not valid. Okay, we have two other options. Let me write them and we simplify them. Now option C, there exists x comma alpha of x. This entire thing unit implies beta, implies for all x comma unit. Whenever I write comma after for all x, then this comma is for, this for all x is for entire remaining unit. You should remember it. Okay. Now let me convert it. There exists x alpha of x. It is alpha 1 plus alpha 2, isn't it? So alpha 1 plus alpha 2 implies beta whole implies, now see, for all x for entire thing, alpha 1 implies beta. So unit number 1 into unit number 2. What is unit number 2? In the place of x we should write x2. That means alpha 2 implies beta, isn't it? So this is the final conversion. Now let me keep this implication as it is, and let me simplify this entire part and this entire part. So it will become alpha 1 plus alpha 2 implies beta. A implies B is nothing but A bar plus B, isn't it? A bar. Alpha 1 plus alpha 2 whole bar plus beta implies, this will become alpha 1 bar plus beta into alpha 2 implies beta, alpha 2 bar plus beta, isn't it? Now this will become a plus b whole bar, a bar, that means alpha 1 bar into alpha 2 bar plus beta implies, so if I simplify this one in digital, beta plus alpha 1 bar into beta plus alpha 2 bar is nothing but beta plus alpha 1 bar into alpha 2 bar. Remember it, okay? That is distributive rule. So it's like this, a plus b into a plus c is a plus bc. That's why this one. Now you see, this component is beta plus alpha 1 bar into alpha 2 bar. This component also beta plus alpha 1 bar alpha 2 bar. Then whenever you take left side true, automatically right side will become true. Then you never get true false case. That means this formula cannot be false. To make this formula false, we have only one combination, that is left is true, right is false. But we don't get that chance because left and right components are same formulas. You understand? That's why option C is a valid formula. Okay, now we'll go to option D. Let's convert this one. For all x alpha of x, it is nothing but alpha 1 into alpha 2, isn't it? Implies beta. This entire thing is 1 unit, implies, so for all x is for total formula, alpha of x implies beta. Two times we should write. First time alpha 1 implies beta into second time alpha 2 implies beta. Okay, let's simplify this one. Alpha 1 into alpha 2 implies beta is nothing but alpha 1 alpha 2 whole bar plus beta, isn't it? Implies this one, alpha 1 implies beta, alpha 1 bar plus beta into alpha 2 implies beta is nothing but alpha 2 bar plus beta. Now this will become beta plus alpha 1, I'm simplifying this one, alpha 1 bar plus alpha 2 bar, because alpha 1 alpha 2 whole bar is alpha 1 bar plus alpha 2 bar, implies this is beta plus alpha 2 bar into beta plus alpha 1 bar is nothing but beta plus alpha 1 bar into alpha 2 bar. Now see, whenever right side is false, left side can be true. I will show you that. Try to make right side false now. Just it's an attempt. Okay, for that plus, when you have plus it's r. Whenever you have r, left and right both should be false. False or false is false, right? For that beta should be false. Alpha 1 alpha 2 whole bar, alpha 1 bar into alpha 2 bar should be false. Remember it. Okay, then this beta should be false, but overall should be true. For that we have choice, alpha 1 bar plus alpha 2 bar. Now the problem is, can we make alpha 1 bar plus alpha 2 bar true and at the same time alpha 1 bar into alpha 2 bar false? Yes. What you do is, take alpha 1 bar as true. Okay, take alpha 2 bar as false. Understand? Alpha 1 bar true, alpha 2 bar false. Then alpha 1 bar will become true, alpha 2 bar will become false. Then true plus false, true. True plus false, true. Left side will become true, but right side will become false. So again you got true false combination. True implies false is false, isn't it? That's why this formula is invalid. So option C is right. So this is one very difficult question which is asked in some gate. If you answer this kind of questions, okay, then you get into top 10, remember. But to answer this kind of questions, you need rigorous practice. Whatever the way I solve the question, if you keep practicing these kind of things, after some time you will master it and you will be definitely solving this question within half minute. Okay, you need rigorous practice. Understand? Let's see one more example. This time I use a different technique, that is, conceptual model, where I use interpretations to understand the formulas. Okay, we understand the formulas and appropriately we fix the truth values, and based on that we answer it. Okay, question is, which of the following is valid? Valid formula is always true. If a formula is not valid, we can make assignment so that formula is false. Remember that point first. Now my target, really it is not valid, I can get a true false combination. And one more thing, this is not logical implication. In the exam, if they don't mention anything and if they give this kind of symbol, that is just implication. Usually when they give formulas, though they give this symbol, it's implication. otherwise they mention. Okay, now these are all implications. Now given a formula, whether it is valid or not, isn't it, what I do is I try to understand this point first. Okay, and this entire thing is one unit. Really it's a valid formula, it never gets true false combination, isn't it? First assume that it's not valid, then definitely you get true false combination. Let me try it. If I get it, this is not valid. If I don't get it by after trying all possibilities, then this definitely should be valid and stop the process, right? Because we have to identify the valid formula. If this is valid, stop it, right? Let's try systematically. First come to this point. So for all x alpha implies beta formula should be false, but it is a formula. How to interpret it? For that I use alpha as physics exam this time. Okay, so like p of x, beta as chemistry exam. So x is a student. So some of the students has this doubt. Alpha is a formula, but where is x? Usually you will have p of x, q of x kind of things, right? But x is missing here in the formula. It is there, but it is inside. Okay, so alpha is a formula like p of x, but they mention like alpha. Okay, but there is a variable x which is inside alpha. Okay, now it's like this. Every student x, alpha implies beta, physics implies chemistry. Okay, that means for every student whoever pass physics exam, then they pass chemistry. Okay, now read it again. Every student, if alpha, if they pass physics, then they pass chemistry, they also pass chemistry. So such kind of formula we have to make false, isn't it? For that what I do is, every student who pass physics, if they pass chemistry, then I can't make it false. For that, at least one student should be there, correct? And he should pass physics exam, but he should fail chemistry exam. Here P means alpha, okay? Alpha. Q means beta. So there should be one student who pass physics and fail chemistry. Then definitely saying every student who pass physics also pass chemistry is absolutely wrong. Hence formula will become false. Remember it. Okay. So finally I made this formula false for that. This is the justification. We need some student like this. Understand? Now at the same point of time we should make this formula true. First read it. What is the meaning of this one? For all x alpha means every student pass physics exam. What is for all x beta? Every student pass chemistry. But this entire formula should be true. For that, one easy technique, make this formula false. Okay. False implies anything is true. Agree? Okay. Target become for all x alpha should be false. Go to interpretation again. Every student who pass physics exam, that statement should become false. For that, at least one student should fail this exam. Otherwise, if everyone pass, this formula, this statement will become true. But my goal is what? I want to make for all x alpha false. So you ask me why? Why not for all x alpha true? That is also possible. But if for all x alpha is true, then for all x alpha beta should be true. We should fix like this. Our goal is making left side true. For that you have two possibilities. True implies true, true. False implies anything true. That's why I am going for easy technique. What is easy technique? Making for all x alpha false. That's easy, because for that only this component should be adjusted and we never need to adjust this one, isn't it? That's why. How to make for all x alpha false? Simple. Take one student. There should be one student, okay, who should fail physics exam. Let's say Rani. Why I am not taking Raju? Because Raju already passed physics exam, isn't it? That's why I can't take Raju. Let me take Rani. Let's say Rani fail physics exam. Then what happens? Alpha is false. Then automatically every student pass physics exam is wrong because Rani failed physics. Then this overall formula, see here, this will become false. Okay, false implies anything? True. True implies false is false. Overall this formula is false. Understand? That's why if you interpret the formula and understand it easily, then you can easily solve the problems. Okay. Now interpret this formula again. every student pass physics exam, then there should be some student who pass physics and chemistry. Absolutely wrong. Understand again. If every student pass physics exam, then there exists at least one student who pass physics and chemistry. Why? It's not at all a proper reasoning, right? So now I can get a contradiction. That means I can get a assignment where this formula is false. I will show you. My target is right is false, left is true. I can get it. I'll tell you how. There exists alpha and beta. Try to understand this one. There is some student who pass physics and chemistry. That should be false. Then definitely every student should fail in physics exam or fail in chemistry exam. Why? Because there is some student who pass physics and chemistry, statement is false. There should not be such student who pass both exams. That means all the students, they should either fail in physics or fail in chemistry. Remember it. Now, but every student should pass physics exam. Yeah, it's possible. Now see, in the world, if there are two students, let's say Raju, Rani, our goal is what? Left is true, right is false. How to make left true? Every student pass physics exam true, then Raju should pass physics exam. Alpha means physics, beta means chemistry. Raju pass physics, Rani pass physics. That's it. Then left is true. But can you guarantee that some student who pass physics and chemistry? Up to now chemistry is not at all fixed. You have any option to fix chemistry? Can you make this option such a way that this formula false? Yes. If every student failed chemistry, still left is true because every student pass physics. But some student pass physics and chemistry is absolutely wrong. Okay. So for this evaluation, left is true, right is false. That's why this is invalid. Understand? Now we'll see option C. Okay. For all x, alpha or beta implies there exists x alpha implies for all x beta. Same target. Left is true, right is false. That is what I am trying. Okay. Now right side formula, if you see it, we have to make it false. Then this component should be true. This component should be false. Okay. Please watch. If you don't understand this concept, why I am making this true and false, please watch my propositional logic videos again. In that propositional logic, I taught you this logic to make a formula false. Whenever you have A implies B formula, A true, B false, then it is false. I am hoping that you understand this. So finally, there exists x alpha should be true. That means there is some student who pass physics exam. Such kind of formula should be true. For that, definitely I should have a person like Raju who should pass physics exam. Remember it. Otherwise it won't happen. Now every student pass physics exam is false. That means what? Not every student pass physics exam. That means what? At least one student should fail in physics, isn't it? Let me take one student called Rani. Okay, different student. That Rani should fail in physics exam. Ask why? Because every student pass chemistry is wrong. For that, some student should exist who should fail in chemistry, isn't it? What about physics exam? Anything. What about Raju's chemistry exam? Anything, right? So you have some student like Raju, you have some student like Rani. So that this is true, this is false. Remember it. Now come here. Every student pass physics or chemistry. Yeah, Raju, do you pass physics? Yes. Rani, do you pass chemistry? No, but do you pass physics? Question mark. Yes, we can, by carefully adjusting this to true. Yes, every student pass physics or chemistry. Physics or chemistry, isn't it? So that means yes, we can make it true. Still, by making this one true, this one false, this one true, we can make this formula false. Understand? Structurally, so we made, just see the summary, we made this formula false. For that, Rani is a student who should fail in chemistry. Now to make some student pass physics exam true, Raju should pass physics. Now every student who should pass physics or chemistry, yes, it is possible with this example, right? So finally I have tuned an example where left, this is true, this is true, this is false. So what happens? True implies false, false, isn't it? This entire component become false and this entire component become true. Such a way I adjusted. That's why this formula is not valid. Understand? See option D. Target is left is true, right is false, isn't it? So that true implies false, false. Just attempt. I don't know whether I can succeed or not. For that, again A implies B kind of formula. Then left is true, right is false. Now, can we achieve it? We'll see. For that, to achieve it, every student pass chemistry exam should be false. That means saying every student pass chemistry is wrong. For that, at least one student should fail chemistry, isn't it? Again, some students have this doubt. That is, sir, every student should fail chemistry. No, not required. If I say every student pass chemistry is wrong, for that some student is enough to fail chemistry. Okay, so that's why let's say her name is Rani. Physics exam and chemistry exam. We have chart like this, correct? Up to now, there are other lot of students. Okay, now to make this formula false, definitely at least one student should fail chemistry. For that I am picking Rani as that kind of candidate. So Rani failed chemistry. What about physics? So let me keep options open. So it can be anything. I don't know. But definitely Rani failed chemistry. Now see this one. For all x alpha should be true. For that every student pass physics exam should be true. For that Rani also should pass physics exam, isn't it? So put right mark. Not only that, for every student keep right mark. Now finally, I have adjusted the values of students so that this right side formula is false. At the same time, you should make left side true. Okay. What is the left side formula? Left side formula says that every student, whoever pass physics, should pass chemistry. But impossible because already with these assignments, whoever passed physics cannot pass chemistry because Rani already passed physics and failed chemistry. Because of Rani, this formula automatically become false, right? Why? Think again. Interpretation. Interpret again. Every student, whoever pass physics, should pass chemistry. Impossible because Rani cannot do that. That means this formula is violated. But our target was making left true, right false. You couldn't achieve it, then so what, sir? In other cases, like see the possibilities: true, 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 false, false, true, false, false. In other cases, true implies true, true, false implies true, true, false implies false, true. Automatically, this formula is true. Only in this case, it could be false, but you couldn't achieve that case. That means this formula cannot be false at any time. That's why option D is a valid formula. In that way, you can answer first order logic questions.